In this video, we will solve the mathematical economics questions asked in UGC NET Economics paper of 2025. So, like, subscribe and share this channel with your friends.
The question is given utility function as utility is a function of two goods x and y, which is equal to x plus 2 times y plus 1. Price of good x is $4, price of good y is $6, and income of the consumer is $130. We need to find out the consumption optimal bundle, rather optimal consumption bundle in this case. Okay, so this is actually the maximizing concept. We want to maximize the utility of the consumer, which is being given by, so we have x plus 2 times y plus 1 subject to the budget constraint. That is, what will be the budget constraint? That will be price of x times units of good x plus price of y times the units of good y should be equal to the income of the consumer. Okay, so can we rewrite the utility function as? So let us solve it first. So we have x plus 2 times y plus 1. So can we rewrite it like this? So multiplying first with respect to x, so we have x into y is xy, then we have x into 1 is x, then we have 2y plus 2 ones are 2. So our utility function is xy plus x plus 2y plus 2. Okay, graphically what exactly is meant by this? So let me be within the limit. So you get x on the horizontal axis, good y on the vertical axis with the given budget set. So we have this given budget set, and specifically we are being given, so we have price of x is 4, so we have 4 times x plus price of y is 6, so we have 6 times y should be equal to, we have 130. Okay, so dividing both sides by 2, so we get 3x plus, rather 2x. Okay, so dividing both sides by 2, we get 2 to 4, here we get 3y is equal to, so here we get 2 6 are 12, then we have 2 5s are 10. Okay, so with the given budget set, consumer want to reach highest possible satisfaction, and optimal bundle will lie at a point where the indifference curve and the budget line are tangent to each other. So at this point what happens, our marginal rate of substitution between good x and y should be equal to the ratio of the prices, price of x upon price of y. So this denotes the slope of the indifference curve, this ratio denotes the slope of the budget line. So MRS, as we know, it is simply the ratio of marginal utility of x, good x, upon marginal utility of good y, and it should be equal to px upon py. Px is 4, py is 6, so we have 4 upon 6. Then marginal utility of good x is simply the change in the magenta. So let me use another color. The change in the change in the total utility due to the change in the consumption of good x, that is marginal utility of good x, divided by marginal utility of good y, means the change in the total utility due to the change in the consumption of good y. 4 upon 6 can be written as 2 upon 3. Okay, which implies du upon dx means the derivative of this function partially with respect to x. Derivative of x is 1, so we are left with y, plus derivative of x in the second term is 1, and derivative of the last two terms is 0 because we are taking the derivative with respect to x, divided by we need to partially differentiate again with respect to y this time. So derivative of y is 1, so we are left with x, plus derivative of x is 0 because we are taking partials with respect to y. Derivative of y is 1, so we are left with 2, and derivative of a constant, we know it is equal to 0, and we equated with the slope of the budget line. Doing cross multiplication here, we have 3y plus 3 is equal to 2x plus 4. Solving for y, so we get 3y is equal to 2x, transpose it here, it gets subtracted, we get 1 only, or y is equal to 2x plus 1 upon 3. Now we plug this value into the budget constraint, so we get 2x plus 3, the value of y is 2x plus 1 upon 3 should be equal to the income of the consumer. 3 and 3 gets cancelled, so we have 2x plus 2x, so we get 4x plus 1 is equal to 65, which gives us 4x is equal to 64. Transpose it here, it gets subtracted. Dividing both sides by 4, x will be equal to 4 1s are 4, even 4 6 are 24. So optimal consumption of good x will be 16. So we have 16 here. What about optimal consumption of good y? Plug x is equal to 16 into this function, so y will be equal to, so we have 2 into 16 in place of x, we substituted with 16 plus 1 upon 3, so sharat sharage 32, so we get 32 upon 3, rather 32 plus 1 upon 3. I am not within the visible range, so we have here 3, here we have 3, that gives us y will be equal to 33 upon 3, which is equal to 11. That means optimal consumption bundle, that is x star y star will be equal to 16 and 11. The question is, given the total cost function is 100 plus 0.015 x square, where x is the output and TC denotes total cost, and total revenue is R is equal to 3 times x. We have to find out the maximum profit. Okay, so what we are being given here, we are being given the total cost function. So we have the total cost function is, that is TC is equal to 100 minus 0.015 x square, and we have the revenue function is, total revenue is 3x. Okay, so for to find out the maximum profit, we know that for a profit maximization condition, we equate the marginal revenue with the marginal cost. So since this is total revenue, marginal revenue will be the derivative of this or with respect to x. So differentiating this with respect to x, derivative of x is 1, so we are left with 3. That is our marginal revenue. And we also need to find out the marginal cost, that is the change in the total cost due to the change in the output. So differentiating this function with respect to x, derivative of a constant is 0, derivative of x square is 2x, so we get here minus, rather it is here plus. Okay, so we get 2 into 0.015, it will become 0.03x. Okay, equating marginal revenue with marginal cost gives us 0.03x should be equal to the okay, we write here the marginal revenue on, or rather marginal cost on this side and marginal revenue here. Okay, which implies 3 upon 100 is equal to, rather 3 upon 100x is equal to 3. Okay, cancelling 3 on both sides, so we get x is equal to 100. Okay, profit maximizing output is 100, but we are supposed to find out the maximum profit. Plug, or we know that total profit is equal to the total revenue minus the total cost. Total revenue is this 3 into x, so x is 100, so we write 3, or let's write the total cost function, total revenue function first. So 3x, to this we subtract the total cost, which is being given us as 100 plus 0.015 x square. Doing this, we evaluate this profit at x is equal to 3. So here we get 3x minus 100 minus 0.015 x square. To find out the maximum profit, plug x is equal to 100 in this equation. So profit when x is equal to 100 will be equal to, so we have 3 into 100 minus 100 minus, so point this is 10 to 100 to 1000, we can write 15 upon 1000 into x square means 100 square, so 100 square is 4 zeros, so 1 is 10 is 100, 1000, 10,000. Okay, so here these 3 zeros gets cancelled, we are left with, here it is 300 minus, then we get 100, here we are left with 15 into 10, which is minus 150. Okay, so profit will be equal to 300 minus 100 is 200, so we have 200 minus 150, which gives us maximum profit will be equal to 50 in this case. Question is to find out the impact on output when the tax increases. The question is, if marginal propensity to consume is equal to 0.8 and tax increases by 100, what is the impact on the output? So we have the marginal propensity to consume is equal to 0.8, change in the tax is equal to 100, and we are supposed to find out the change in the output. Okay, so this is the tax multiplier question, and tax multiplier is being given by minus times MPC upon 1 minus MPC. Okay, tax multiplier shows us the change in the output due to the change in the taxes should be equal to what is MPC, it is minus 0.8 divided by 1 minus 0.8. So we will get here minus 0.8 upon 0.2. So 2 ones are 2 fours are, we get here negative 4. Change in output we are supposed to find out. Change in the taxes is being given as 100, should be equal to negative 4. That means doing cross multiplication, change in the output will be equal to minus 4 times 100. That means output will decrease by 400 units. So del y will be equal to negative 400. So we will say output will decrease by 400 units. Okay, if it was an option in the question. The question is evaluate the integral of x plus 3 upon x plus 5 with respect to x. Okay, so how do we solve this kind of question? So let us write it like this. So we have the integral from x plus 3 divided by x plus 5 dx. Okay, now we cannot solve it directly, so we have to use the integration here. So can we rewrite it like this? We have x plus 3, we need to form x plus 5 in the denominator. So can I add 2 and subtract 2, then divided by x plus 5 dx. Okay, that means we will get here, so we have x here, 2 minus 2 is 0, so adding and subtracting 2 doesn't disturb the given question. So we have x, 3 plus 2 is 5, so we write here x plus 5. Then we have, let us divide it by x plus 5 here. Okay, I am expanding it here, so then we have minus 2 divided by x plus 5, and we need to evaluate it with respect to x here. That means we will get, so this term gets cancelled, so we have the the integral of 1 dx, then we have minus 2, let us take minus 2 common, so we have here 1 divided by x plus 5 dx. Now the integral of 1 with respect to x is simply x, we know it, so it is x. Then we have minus 2, the integral of 1 divided by 1 x plus 5, its integral is log of x plus 5, and we add the constant of integration here. Okay, so we will get x minus twice ln of x plus 5 plus c, which is the constant of integration. So this is how do we evaluate the given question. Is given demand function is p is equal to under root 9 minus x, where p is the price, x is the quantity. We have to find out the consumer surplus when quantity demanded is 5 units. Okay, so this question is about the consumer surplus. So what we are being given here, we have the demand function is p is equal to under root 9 minus x. So we have non-linear demand function, and we need to find out the consumer surplus when quantity demanded is equal to 5. Okay, so since this is the non-linear demand function, we have to use the definite integrals here. Now when x is equal to 5, what will be the price? So p will be equal to 9 minus 5, which is equal to, so in place of x I have substituted it with 5, so it is under root 4, and we know under root 4 is equal to 2. Okay, now graphically what exactly is meant by this? If I draw a simple graph here, so we have the quantity demanded on the horizontal axis, price on the vertical axis, So we have a non-linear demand function like this. Okay, so this is our demand function. We need to find out what will be the consumer surplus. So let us do it like this. We need to find out the consumer surplus when quantity demanded is equal to 5. So when quantity demanded is equal to 5, we need to find out the consumer surplus. And we have the price is 2. Okay, we know that what is consumer surplus. It is simply the difference between the consumer's willingness to pay for a product and the actual price he is paying for a product. Okay, graphically it is simply the area which is below the demand curve and above the equilibrium price. So the area of this shaded portion gives us the consumer surplus. So consumer surplus will be equal to, so consumer surplus is equal to the definite integral from 0 to equilibrium quantity, which is x here, and we we take the integral of demand function, that is p dx. From this we subtract the total expenditure. So we have like this. So from this we subtract the total expenditure, that is p into x. So p is this, x is this. Okay, which means consumer surplus will be equal to, so we need to take the definite integral from 0 to equilibrium quantity is 5, and we differentiate this 9 minus x. So can we rewrite it like this, 9 minus x raised power 1 upon 2, and from this we subtract the total expenditure, which is p into x. Okay, now to solve this integral we need to use the substitution method. Okay, and let me write it here, then I will rub this out. So let us suppose 9, or let me write, let t is equal to this 9 minus x. 9 minus x, okay, differentiate or take the differential on both sides. So derivative of t is dt is equal to derivative of constant is 0, derivative of x is dx. So we get minus dx. Okay, so here we have dx, and let me write it here with respect to x. We are taking the integral here. Now what will we do here? So in place of 9 minus x, so let me rewrite it here. So we have definite integral from 0 to 5. In place of 9 minus x, it is equal to t raised power 1 upon 2, and in place of dx, since dx is equal to dt, that means dx will be equal to, if I multiply both sides by minus 1, so we will get minus dx, or we will get it like this, minus the definite integral from 0 to 5 t raised power 1 upon 2 times dt. Okay, so in place of minus dx we have dt. So we took this minus common here, or out of the definite integral side. Now if I differentiate it, rather if I take the integral of this function with respect to t, what will we get? So we have minus the definite integral, the integral of t raised power 1 upon 2 is t raised power 1 upon 2 plus 1 divided by 1 upon 2 plus 1, and we evaluate it from 0 to 5. Okay, rewriting it, so we will write it minus, so this is t raised power 3 upon 2 divided by 3 upon 2, and we evaluate it from 0 to 5. Okay, so if we further solve it, so 3 upon 2 will become 2 upon 3, and if I take it common, so we get minus 2 upon 3 here, and we integrate it from t raised power, we have t raised power 3 upon 2, and we evaluate it from 0 to 5. Okay, that means consumer surplus will be equal to, we have minus 2 upon 3, and we evaluate this, and we know t is equal to 9 minus x. So we have 9 minus, we evaluate it from upper limit, and then we subtract and evaluate, or let us first write 9 minus x raised power 3 upon 2 from 0 to 5, and we subtract the total expenditure. P into X means P is 2, X is 5. So we have 2 into 5, which is equal to 10. So here we have 10. Okay. Now let me rub this out. So this time the consumer surplus question was a tricky one. That gives us consumer surplus will be equal to, we have minus 2 upon 3. Then we evaluate this term at upper limit, then we subtract and evaluate it at lower limit. So upper limit is 5, can we write 9 minus 5 raised power 3 upon 2. Then we subtract and evaluate it at lower limit, that is 9 minus 0 this time. So in place of X we have then 0. So 9 minus 0 raised power 3 upon 2. From this we subtract the total expenditure. That gives us consumer surplus will be equal to minus 2 upon 3. 9 minus 5 is 4. So we have 4 raised power 3 upon 2 minus, now here we have 9 minus 0 is 0. So we get 9 raised power 3 upon 2, and we subtract the total expenditure. So consumer surplus will be equal to minus 2 upon 3. Now can we write it as so here we have 4 can be written as 2 square, then we have 3 upon 2, and in place of 9 we can write 3 square raised power 3 upon 2, and we subtract minus, or rather 10. So consumer surplus will be equal to minus 2 upon 3. Here this 2 and 2 gets cancelled, we get 2 to the 4 to the 8, minus here this 2 gets cancelled, so we will get 3 3s are 9, 3s are 27, minus 10. That gives us the consumer surplus will be equal to minus 2 upon 3, subtracting 27 from 8, it is minus 19. Then we have minus 10. Our consumer surplus will be equal to, so minus into minus is plus, 2 into 19 is so we get plus 38 upon 3 minus 10. So consumer surplus will be equal to 38 minus 3 tens are 30 upon 3. Our consumer surplus will be equal to 38 minus 3 is 8 upon 3. That means which is equal to 3 2s are 6, 7, 8, so 2 upon 3. So this will be our consumer surplus. The question is regarding probability. A candidate is selected for an interview for 3 posts. For the first, second and third posts, there are 3, 4 and 2 candidates respectively. Find the probability of getting selected in at least one post. Okay, so we have a person who got selected for interview for 3 posts. Okay, for the first post there are 3 candidates here, or second post there are 4 candidates, for the third post there are 2 candidates. We need to find out the probability that the person is selected for at least one post. Okay, let us denote the event of getting selected for first post by A, for second post by C, and for third post by C. Now the probability of getting selected in the first for the first post, or in this case will be equal to, so since there are 3 candidates, the probability of getting selected in the first post is 1 upon 3. Likewise, probability of getting selected in the second event will be 1 upon 4, and probability of getting selected for third post is, that is probability of C will be equal to, there are 2 candidates, so there are half chances of getting selected. Now to find out that the person gets selected in at least one post, how do we find out this? So we need to find out probability of getting selected in at least one post. It is being done by 1 minus the probability of getting selected in none of the posts. Okay, to find out the probability of getting selected in at least one post, we find out it by subtracting the probability of getting selected in not any of the posts from one. Okay, now what is the probability of not getting selected in the event A? So let us denote it by P A prime, which will be equal to 1 minus the probability of getting selected. Probability of getting selected is 1 upon 3, so here we get 2 upon 3. Probability of not getting selected in the second post, it will be equal to 1 minus the probability of getting selected, which is 1 upon 4. So here we get 3 upon 4. Probability of not getting selected in the third post will be equal to 1 minus the probability of getting selected. So it comes out to be 1 upon 2. Okay. So we will get here 1 minus probability of A prime intersection or complement B intersection C complement. Why? Complement rather. Here the events are independent, that means we need to multiply them. That means probability of getting at least selected in one post will be equal to 1 minus probability of A complement times probability of B complement times probability of C complement, which will be equal to 1 minus, so here we have 2 upon 3, so we have 2 upon 3 into 3 upon 4 into 1 upon 2, so 3 and 3 and 2 and 2 gets cancelled, we get 1 minus 1 upon 4, that is equal to 3 upon 4. That is the probability of getting selected in at least for one post is 3 upon 4. Question is, out of 40 students in a class, 25 know Hindi, 20 know both Hindi and Urdu, and every student knows at least one. Find the number of students who know only Urdu. Okay, so total number of students is 40. Okay, so we have total students is 40 and 25 know Hindi. So can we write the number of students who know Hindi or Urdu, okay, will be equal to 40. Since every student knows at least one language, therefore number of students who know Hindi or English will be equal to 40 here. We are also being told that the number of students who know only Hindi is equal to 25 and 20 students know both Hindi and Urdu. That means number of students who know Hindi and Urdu is equal to 20. Okay, using the principle of inclusion or exclusion, we know that N H union U will be equal to NA plus NB NU. Here we have NH. It shows the total number of students in the class will be equal to the total number of students who know Hindi plus total number of the students who know Urdu minus the total number of students who know both languages, Hindi and Urdu. Okay, this is being given us as 40, so we write here 40 is equal to number of students who know Hindi is 25, number of students who know Urdu we are supposed to find out, and the number of students who know both Hindi and Urdu, it is being given as 20. Okay, so 40 is equal to 25 minus 20 is 5 plus N U, that means number of students who know only Urdu will be equal to 40 minus 5, which is equal to 35.